All right, so let's go ahead and go over what you guys came up with. So for problem number 1, we have an example of a problem, just kind of like what we did yesterday, where we took a problem and broke it apart into its different components, and then identified the properties that represented from one step to the next. So in this problem, they only want you to identify what property of operations did she use in step 3. So as we are getting here, in step 3, when she went from step 2 to step 3, what did you notice she did? Was it commutative property of addition, associative property addition? Did she do distributive property? Was she subtracting a number is the same as adding its inverse, which we know is additive inverse? Or was it the opposite of a sum is the sum of its opposites? So what did you guys come up with? Wow, don't all respond at once. Hayden, what did you guys come up with? Associative property of addition. And why would you say that? Well, I mean, what does associative property state happens? Who can help? Okay, well, but you weren't off yesterday when we learned about it. What about it, Sebastian? The grouping changes. Did the grouping change? So here originally we had 21 on the outside and a negative 24 on the inside. Now we have a 21 on the inside and a negative 24 or minus 24 on the inside. So that was one of the properties that did occur, right? We did change the grouping. So yes, associative property did occur. That's a true statement. Something else also occurred though. What else also could have occurred? We know associative property happened because of this right here. This now became the parentheses around these two. But what else happened? Jeremy? Not distributive. Christiana. Not commutative. So take a look. Right here we have a plus and a minus, right? We have a plus and a negative. Do we have a plus and a negative anymore?
No.
No. It's now just a what? Subtraction. So what happened, John Luke?
She's subtracting a number is the same as adding it.
Yeah. So they just went in the reverse of it, didn't they? They took the adding of a negative and changed it now to subtraction. They did an additive inverse and reverse, okay? So subtracting a number is the same as adding its inverse. These two things right here are the same. They mean the exact same thing. Adding an opposite is the same as subtracting. All right, let's take a look at the second problem. Maria and Shane both started working on a math problem and we're comparing their work in their class. So they want to know which one of them is correct. Are either of them correct? And then finishing off the problem. So the question says that Jessica lent her friend, or Jessica's friend lent her $5, right? If she lent $5, what kind of integer is that when you are being lent money? Positive or negative, guys? Negative, right? It's lent is another way of saying you borrowed money. So we know that that's going to be a negative 5. So did they both start off with a negative 5? Did they both start off with a negative 5? Yeah, they both started off with a negative 5. So that portion is correct here. Okay, later that day, Jessica gave her friend back $1.34. So if she gave it back to her, is that a positive or negative? Right? She's paying some of it back. That's a positive right here. So we're talking about a positive 1 3/4. Is this going to represent a positive 1 3/4? If it's subtracting a negative, will that eventually be a positive 1 3/4? Yeah, that double negative here is eventually going to be a positive, and they both happen to have that. So they both have the problem set up correctly. Now let's look and see how they worked it out. So for Mariah, what she did is she took this minus a negative 1 3/4 and she changed it to where you have a positive 1 but a negative 3/4. Okay, she has a positive 1 and a negative 3/4. Is that correct? Why? Yeah, so which one is incorrect, the 1 or the 3/4? The 3/4. The 3/4 portion right here is incorrect. This part should also still be positive because the whole entire mixed number is a positive 1 and 3/4, so that if we were to pull it apart, separate it, right, the opposite of the sum is the sum of its opposites, okay, then that would be a positive 1 and that would be a positive 3/4. So Mariah messed up in the fact that she put the fraction portion still as a negative. Whereas Shane still kept the fraction and the whole number portion as both positives. So Shane does have that portion correct. Now, if we were to go ahead and continue the process, we could then go to using our associative property. With our associative property, I could state that negative 5 plus 1 could be inside of parentheses, and that plus 3/4 could be on the outside of parentheses. I could use that associative property in order to rewrite my addition. Okay, now I can go ahead and combine this together. What is negative 5 plus 1? Negative 4. So we would just have negative 4 plus a positive 3/4, and then we can simplify from there. You should have gotten negative 3 1/4 as your final answer. Okay? All right. Let's head it on over to the next page. We're going to talk real quickly about some of our integer rules for addition and subtraction. And then we're going to focus on how to utilize counters and number lines for addition and subtraction as well. All right. So integer rules. These are things that you learned last year. Should spark some memory for you. But when you are adding integers, same signs, you add and keep. If they are both positive, you add them together and you keep it positive. If they are both negative, you add it together and you keep it negative. Now, with the rules, the nice thing is you do get to utilize a calculator now. You don't have to worry so much about the rules anymore because you do get to use that calculator. But essentially, when we are writing that negative 2 plus negative 6, it's essentially saying you've got a negative on the outside, and with inside parentheses, you're just adding the bases together. Because of the fact that they are identical signs, you're taking the sign outside and just adding the base values together, and then keeping the sign the same. So that would be a negative 8. Again, this is a situation in which they are both negative, and that's why we are able to do that. Same thing in the fact that they are both positive. Essentially, what's actually happening here is that you're taking a positive sign on the outside and you're adding the bases of them together and keeping your sign positive. Now, when we have different signs, when our signs are different, then you are subtracting like you normally would, high minus low, and then you're going to keep the sign of whichever one is your larger base. Not what's the larger negative number, but what is the larger base. Remember, the negative sign changes the quantity of your base, but the base itself is still a 2, a 5, an 8, whatever it might be. So in this case, we have negative 4 plus 7. So what we're going to be doing is we're going to take 7 and subtract 4 because the bases are what we're focusing on. I'm ignoring the sign for the moment, and I'm just focusing on the base. So highest minus lowest. Now I know 7 is my highest value, so I'm going to focus on what sign it is. Was 7 originally a positive or a negative? It was originally a positive. So that means that our answer is going to be a positive answer. So it is a positive 3. In a situation like negative 8 plus 2, again, they are differing signs that we are adding together, so we're really just going to do 8 minus 2. And again, the 8 was the higher base? Was 8 a positive or a negative? It was a negative. That means that our answer is going to be a negative. So we would have -6 as our answer. Okay, when we are subtracting integers, like I told you guys before, we do not actually subtract. We are always really adding. Subtraction is just addition of the opposite. And again, that's called the additive inverse. You are adding the opposite. So it is a quick 3-step process. The first step is to keep the first value in your problem the same. Nothing changes to it. If it was a negative, it stays a negative. If it was positive, it stays a positive. The only things that are going to change is the subtraction is now going to become addition, and that the second term in your problem is going to become its opposite. The second term will become the opposite value. So if we're taking a look at -15 minus the 2, -15 minus 2, I'm going to split this up into 3 parts. -15, a subtraction sign, and then a 2. The reason I always tell kids draw the wall is because a lot of times you see the minus sign and you automatically assume that 2 was negative. But this doesn't say minus a -2, it says minus a +2. Okay. When we get into the process of keep, change, change, then things are going to start flipping around. So we're going to keep the -15 just as it is. We're going to change subtraction to addition. And we're going to change the 2 to its opposite, which is a -2. Now we can follow the rules that we had above. Are these same signs or different signs? Same, right? They're same signs. They're both negative. So since they are same signs, we add and we keep. So that becomes -17. Okay, for here we have -5 minus a -4. Again, if you want to draw your little walls to help you separate out which ones are signs and which ones are operations, do that. We start off with keeping. We're going to keep the very first number the same, -5. We're going to change subtraction into addition. That becomes a plus sign. And then we're going to change the -4 into a +4. Okay, now that it's back to an addition problem, we follow the addition rules. Is this same sign or different signs? Different. These are differing signs. So that means what we're really going to do is subtract 5 minus 4. And again, the 5 is the higher number. Was 5 negative or positive? It was negative. So therefore our answer is a -1. Okay, I know that there's quite a few of you who can do this in the head. This is just a refresher for you guys. Some people need a refresher because, as Hayden said, hey, he's been on summer for 2 months. Okay, sometimes people need a little refresher. What I want you guys to do real quickly, though, go through problems 1 through 6. You don't have to show all the work. If you can do it in your head, perfect. I would love that. Move on. I don't need you raising hands. You can just tell me what the answer is. Number 1. Jeremy is like, I'm on it. All right, -5. Remember, there are different signs. We'd subtract. Keep the sign of the larger. Number 2, -9. You guys got to be faster if you want to keep up with them. It's -9. Same signs. Add and keep. Number 3, 12. You got to keep, change, change. Then they're same signs. It's going to be 12. Number 4. -11. You're gonna keep, change, change. Then there'll be same signs, add and keep. So -11. Number 5. -14. Same signs, add and keep. Number 6. -8. You got to keep, change, change, and then they're different signs. So -8. All right. Let's flip it on over to the next page. got a few word problems here. Mount Everest is 29,028 feet above sea level. The Dead Sea is 1,312 feet below sea level. We want to know the difference between these two elevations. That's problem number 1. Problem number 2, in Denver, the temperature in the morning was negative 18 degrees Fahrenheit. By the afternoon, the temperature rose 12 degrees. What is the temperature? So I want you guys to go ahead, take your time, answer those 2 questions. You can work with your group. So problem number 1, who can tell me what they got as their answer? Sebastian? Okay, anybody get anything different? What'd you get? Okay, 30,340. Anybody get the same thing as him? Okay, so he's correct. It is 30,340. So a lot of people make that same mistake. So make sure you're paying real close attention here. Mount Everest is 29,028 feet above sea level. That is a positive value there, isn't it? That is a positive value. Shh. Then we've got the Dead Sea. The Dead Sea is 1,312 feet below sea level. The Dead Sea is a negative value. It is below sea level. We want to know the difference between those 2 elevations. Guys, what operation is difference? Subtraction. So we know that we're going to have to go ahead and subtract because of that keyword difference. So what we are doing is we're focusing on whatever Mount Everest's elevation is going to be, and we are going to subtract the Dead Sea from it. Okay, so I'm pretty sure everybody knew, hey, I need to subtract. Where most of you made the mistake is that you forgot to put the Dead Sea as a negative value. So you just put, oh, I'm subtracting 1,312. But you're not. You're subtracting a negative 1,312. So what we are really going to be doing is we are going to be keep, change, and change. We're going to keep that 29,028. We're going to change this to addition, and we're going to change this to the opposite. So you're actually adding those 2 elevations together because of the fact that one of them was a negative and you're finding the difference. So you're getting 30,340 feet. Be sure to not rush. Make sure you're reading carefully so that you get all details. Okay, problem number 2, Denver, the temperature is negative 18. By the afternoon, the temperature rose 12 degrees. What is the temperature now, Mason? Negative 6. Okay, but we said it rose. It rose. Remember I told you guys before that, you know, when you rise, that could be a positive, but it also could mean addition, right? It means that it could be an addition. Some of those positive terms, those positive vocabularies from yesterday could indicate that it's an addition problem. Some of those negative terms from yesterday could indicate that it's a subtraction problem. So just be aware of whether they are focusing on it as an integer or focusing on it as an operation. So rose means that you are going to be adding your values. So we are going to take the 2 temperatures. The starting temperature was negative 18, and then it rose 12 degrees. So negative 18 plus 12, and that's going to come out to a negative 6 degrees. All right. So now let's take a look. Adding with counters and number lines. Simple process, but I can't tell you how many times I get students that are in the gifted and accelerated classes that think it's so easy that they make mistakes all the time. Okay, you guys always overthink things when you really don't need to. So make sure you're paying real close attention. We are going to model. We are identifying what the expression is going to be modeled by these counters. Okay, so what I want you to do real quickly before we move on, anytime you see a negative, I want you to just go ahead and highlight it in pink. So that way we can pretend like these are our negative counters. So all of our negatives here. And wherever you see the positive counters, go ahead and highlight those in green. So we'll let green represent our positive counters. Okay, so we're just going through and highlighting those real quickly. So as we're modeling through them, For problem number 1, how many negative counters do we have? How many negatives do we have here? Count through. How many negatives? 8. We've got 8 negatives, so I know I have a negative 8. When I'm modeling it with a counter, I'm modeling a combination of these, which is an addition problem. And how many positive counters do we have? 6. So what's being modeled here is the numerical expression negative 8 plus 6. Now remember, yesterday I told you guys that there is such thing as zero pairs, where you can take a positive value and essentially zero it out with a negative value. So I happen to have how many zero pairs here? 6. I have 6 zero pairs, right? I can circle this combination of a positive and a negative, and I can cross it off. And I can do this second one, this third one, fourth one, this fifth one, this sixth one. I can cross all of those off. Those are going to be my zero pairs that can go ahead and cross off. And so what I'm left with is 2 negatives. So that means that my answer is a negative 2. Okay, what about problem number 2? Who can raise their hand and tell me what is the expression? Just the expression, like I did negative 8 plus 6. What is the expression that's being modeled here? Go ahead. Negative 4 plus positive 7. Negative 4 plus positive 7. Okay, how many zero pairs do we have here? Don't be sorry, answer. How many zero pairs? 4. We've got 4 zero pairs that can go ahead and be crossed off. Okay, so that leaves us with what answer? 3. Positive 3, right? Just a positive 3. Okay, what about problem number 3? What is the expression that's being modeled here? Jeremy? Good. Negative 5 plus a negative 2. A negative 5 plus a negative 2. Zero pairs? Do we have any? No. There are no zero pairs in this situation. So then how many total negatives do we have? Negative 7. Okay. Quick, easy, simple process. Hayden, honey, just so you know that I do note checks as well. So you want to make sure that you are taking the notes. All right, flipping on over to the last page. Not the last page of the booklet, just the next page. Last page of the lesson. All right, number lines. How to identify addition on a number line. So taking a look here, when you are modeling addition on a number line utilizing positives and negatives, just keep in mind that negative terms, if we're talking about a negative term, what direction do you think a negative term is going to move? Left or right? Left, right? Negative moves left. Your positive moves to the right. Negatives are going to move to the left. Your positives are going to move to the right. So then when you are working these out, the very first thing that you're going to do is you always start at 0. Whenever we are talking about a problem, we always start at 0 and then we move to a direction. So very first point. Start at 0. So I'm going to draw a little line right here that shows me starting at 0. From there, I'm going to move to the direction of whatever my first term indicates. So my first term here happens to be a negative 6. So I'm going to move 6 units to the left. So starting at 0, I will move 6 units to the left. which ends me at negative 6. Makes sense. My first term was negative 6. I'm going over to where negative 6 is. Now, because I am doing an addition problem, I'm going to move whatever direction my second term tells me from negative 6. In this case, it's negative 6 that I'm moving from. So I'm going to now move 2 units. Am I going to go to the right or to the left?
To the right.
To the right, because 2 happened to be a positive. So I'm going to move 2 units to the right from my ending position. So right above that negative 6, I'm going to draw another line and just move 2 units, and then I'm done. This is my answer. What's my answer? Negative 4. So that means that negative 6 plus 2 is equal to negative 4. We're going to do one more together real quickly, and then I want to be able to let you have time to work on your assignments for today. Okay, we've got 3 plus a negative 5. 3 plus negative 5. Again, where am I always going to start? 0. We're going to always start at 0. That's our first step. So we're drawing a nice lovely line at 0. Okay, step number 2. From there, I'm going to move what direction and how many units? Right 3. We're going to move to the right 3. So step 2, we're going to move 3 units right. So 1, 2, 3 units to the right. Okay, and then my last step, I'm going to move how many units? To what direction? To the left. So I'm going to move 5 units to the left. So right above the 3, I'm going to go 1, 2, 3, 4, 5 units. And that's where I stopped at. So my answer is negative 2. So when we do 3 plus negative 5, we're going to get a negative 2. All right, loaded in Google Classroom, you've got your skills for today. They should not take you very long. Please remember that you need to keep them done on the daily. I've already gone through and checked for your completion of yesterday's skill. If it is not completed, I gave you whatever score you stopped at.